So who can tell me what they think mechanical advantage is? Okay. You gave me an excellent definition for compound machine, but that's not mechanical advantage. What is an advantage? Any advantage. If you have an advantage, what is that? Ethan?
It's like you have a lead on something.
Okay, you have a lead. Something has become better, right? You have, bring it to me at the end. I don't want to know. You have a better chance than somebody else for whatever purpose you're talking about. What does the mechanical advantage of a machine tell us? You've got some notes to take on your paper. Pay attention to where we are. This is number 1. What does the mechanical advantage of a machine tell us? 2 things. It tells us how helpful the machine is. It also tells us how many times the input force is multiplied. Mechanical advantage tells you how helpful your machine is by telling you how many times the input force is multiplied. Who does the input force, the you or the machine? You. You do the input force. So if your machine multiplies your input force by a lot, your machine is more helpful. Does that make sense? Okay. We know there are 6 simple machines. Let's review those before we move on. First is the wedge. The wedge is an inclined plane that moves. Some examples we've talked about are a knife, an axe, and a razor blade. You increase the mechanical advantage of a wedge by sharpening it, making it a thinner, sharper side. We're not going to calculate the mechanical advantage of any wedges, so notice I did not put any formula, any equation for the wedge. However, in number 2 on your paper, you see mechanical or pulley or lever mechanical advantage. As we go through these, I want you to write down the formulas for each of these. The line you see after each type of machine that you need to know the formula for, the line is your division sign. So for each of those, you will write something on top of the line. That line represents divided by something on top. Okay, our next machine is the screw. This is an inclined plane wrapped around a cylinder. Some examples are bolts, augers, and drill bits. And the mechanical advantage of the screw relates to how close the threads are together. The more threads you have, does that mean better mechanical advantage or not as good? The more threads you have, the more the mechanical advantage. The pulley. Here's where we start to actually determine some formulas to use. We know a pulley is a chain, belt, or rope wrapped around a wheel. We know pulleys can change the direction or the amount of force depending on how many pulleys you have and how they're attached. And we know some examples of pulleys are flagpole, the pulley on my window blinds, or on a stage curtain. There are several types of pulleys. Who can tell me about a fixed pulley? Go ahead, Michelle.
That pulley stays in place.
Good. Keep reading.
Okay, wait, can we read that?
What?
Should I read that?
Yes.
Oh, can only change the direction of the force. And then equals 1.
The mechanical advantage of a fixed pulley equals 1. So it multiplies your force times 1. Does that change the amount of force that you apply to the machine? No. What does it change? Changes your direction. We talked earlier, remember when I stood up on the counter to lift the window blind? the same amount of force for me pulling down as it would be for me to lift up. But it's convenient because then I don't have to stand on the counter. The other type of pulley is
movable. You can multiply an effort force but cannot change direction. MA greater than 1.
So this kind does make it easier to lift the object. It does allow you to apply less force and multiplies the force that you apply to the object. So, first formula. This is a general mechanical advantage formula. If you can measure the force in and the force out, you use this formula. Sometimes you can't measure the amount of force it takes. So this goes with your first mechanical advantage equation. MA equals output force divided by input force. Yes? Sure. Cassidy, tell us about our next simple machine. And this is what kind of machine? The lever. What's a fulcrum?
The pivot point of a lever. There are 3 classes of levers based on where the input force, output force, and fulcrum are located.
And we know these because we just learned them. A first-class lever. Tell me where the fulcrum is on a first-class lever.
In the middle.
Fulcrum is in the middle. It's between the effort and the resistance. The resistance is also known as the load. How do first-class levers make work easier? Thomas?
Changing the direction. Effort force and changing direction.
They make work easier by multiplying the effort force and by changing the direction. So they do both. First-class levers are very efficient. Second-class levers. Marlena, what are they?
Resistance is found between fulcrum and effort force. Makes work easier by multiplying the effort force but not changing direction.
And how about third-class levers? Nathaniel?
Effort force is located between the resistance force and the fulcrum. It does not multiply the effort force, only multiplies the distance.
Third-class levers, we said earlier, were the least efficient. They generally don't, they're not easy to use. They don't help you apply less force at all. When you use tweezers, you have to squeeze hard to use the pair of tweezers. However, they do allow you to change the amount of distance. Tyler, tell me about the mechanical advantage of levers.
Input arm length divided by output arm length.
So what is input arm length and output arm length? Keep reading.
Input arm equals distance from input force to the fulcrum.
And the output arm?
Equals distance from output force to the fulcrum.
So if we look at this picture of a lever, pictured here, where's the fulcrum on this crowbar? Bailey, where's the fulcrum? Well, describe what's going on at the fulcrum point. Go up and point to it. Go up and point to it. Remember, the fulcrum is the pivot point. So where's the crowbar pivoting or turning or rocking? Yeah, that's the fulcrum. Good. That spot there is where, go ahead, thank you. That spot there's where the crowbar pivots. So which side is the input arm? Which side is the effort? Roxanne? Left or the right of the fulcrum? It's to the right of the fulcrum. This is the input. And it's this whole distance. Where's the output? Cole? This side is the output. So if you can measure those two parts of your lever, you can calculate how much mechanical advantage it has. Okay, let's continue. Tell me about the wheel and axle, Danielle.
A lever that rotates in a circle. A combination of two wheels with different sizes. Center wheel is termed the axle.
The smaller wheel is termed the axle. And how do you calculate mechanical advantage for a wheel and axle?
Radius is 0 divided by radius of the axle.
Good. Wheel and axle. Radius of the wheel divided by radius of the axle. We all remember from math class what the radius is, right? What's the radius? Right, it's from the middle point to the edge, right? Half the diameter. All right. Jenna, tell me about the inclined plane. The mechanical advantage of an inclined plane can never be less than 1. And how do you calculate it? Good. Length of incline divided by height of incline. If you were doing your homework from before and you didn't get all these yet, we'll come back to them. I have another slide that reviews all these if you missed them. Let's review some terms. We've done this several times. You need to know the variable for these terms. You need to know the unit it's measured in and the unit abbreviation. So what is the variable for length? It's a one-letter abbreviation for length. L. So if you were looking in an equation and you saw lowercase l, you would know that meant length. What is the unit for length? Janessa, sorry. Meters or centimeters is how you will measure length for these problems. And how do you abbreviate, Bailey? How do you abbreviate meters and centimeters? M or cm. M for meter, cm for centimeter. You should be writing. Casey, what would you see in an equation if you were talking about the radius of something? Capital or lowercase? Lowercase. Lowercase r for radius. How do you measure the radius?
The distance?
It's the same as a distance, so its unit would be in meters or centimeters, depending on how big the wheel is, and abbreviated m or cm. Michigan, what variable would you use for height? Good. How do you measure height? What units do you use? Nate? Metric system. They're already up there. Yeah, meters and centimeters. So far, all we're using to measure is a meter stick, abbreviated M or cm. Okay, now we finally get something different. Force. Ethan. Good? What units do you use when you measure force? Newtons, and those are abbreviated? Good. The last one, which looks like it got cut off on your paper, should be mechanical advantage. Sorry about that. How do you abbreviate mechanical advantage? Like, what would you look for in the formula, Tyler? MA. What units do you use for mechanical advantage? Nope. Nope. Try again.
None.
There are none. There are no units for mechanical advantage. So I just put a line through those boxes to remind you there are no units. All right, Thomas, so far so good?
Yeah.
You remember these things? They look familiar? Okay. Let's go on to review those formulas. Make sure you have them all. You can find these equations if I missed one, or if you forget one, or if you don't have your paper, you can find these equations in chapter 5.2. The general equation for using force. You might want to write down the abbreviations for these. MA equals F little o divided by F little I. Output force divided by input force. You might want to write down the abbreviations for these as well on the front, where your equations are. The mechanical advantage of a lever if you're measuring length. I'm telling you what it says. Mechanical advantage of a lever. MA equals LI divided by LO. Input divided by output. Notice, what do you notice about these two formulas? Right, they're backwards from each other. If you're using force, it's output divided by input. If you're using length, it's input divided by output. You have to remember they're backwards. The mechanical advantage of a wheel and axle, abbreviated RW divided by RA. You might want to write these abbreviations down, Thomas. Next to the formulas you already have. Radius of the wheel divided by radius of the axle. And the mechanical advantage of an inclined plane would be L divided by H, or length divided by height. Okay, everybody have these?
No.
Okay, I'll give you a second. Okay, let's try some practice problems. On the back of your paper, you see 3 spots to do these practice problems. The first one says, what is the mechanical advantage of the wheel and axle? So I've given you a picture of a wheel and axle. And this says the wheel has a radius of 45 centimeters. If you can see where this is pointing, the axle, that spot there, has a radius of 9 centimeters. See if you can do the guess method for this problem. I want you to go through and try it first, and then we'll go over it. What is the given information? Oh, just kidding. We'll go over your practice problems tomorrow.